Have you ever wondered if your GraphQL resolvers might be doing more work than they need to? Today, starting with the basics, resolvers should always remain focused and simple. The principle of single responsibility should be your guiding star. Picture a resolver that only retrieves user information. Its sole task is to fetch and return the user's details, nothing more. If you find a resolver accumulating additional responsibilities, such as processing or validating data, consider breaking it down. For instance, / overloaded resolver user, async, parent args context, =, const user =, await context db find user by id args.id, if user last login =, new date, await context.db update user, return user / focused resolver user, parent args context =, context db find user by id args.id. Moving on to handling errors, the goal is to be as graceful as a swan on a lake. Consistency is key. Whether you're using custom error classes or middleware, ensure that every resolver adheres to the same error handling methodologies. Remember to provide detailed yet secure error messages. Here's an example of handling an error with an extensions field. Throw new error, user not found, extensions, code, user _not found, status 404. Utilizing the context wisely can significantly streamline how resolvers share data and manage authentication. Inject services, database connections, or user-specific data into the context to make them accessible across all resolvers in a request. Data fetching deserves a keen strategy to avoid performance pitfalls. Overfetching is a common issue where more data than necessary is loaded, putting unnecessary load on your database. Tools like Data Loader can be a lifesaver here. Consider this setup. Const data loader =, require data loader. Const user loader =, new data loader. Keys =, batch get users, keys. Const resolvers =, query. Handling the notorious N+1 query problem requires similar attention. Batching requests via data loader ensures that multiple related queries are consolidated into a single database call, enhancing performance drastically. Reusability in GraphQL can be beautifully handled with fragments. Define a fragment once and reuse it across multiple queries to keep your code dry and your schema consistent. Fragment user fields on user, ID, name, email, query, get user, EA1. A clear and descriptive schema acts as a good map in the world of GraphQL. Use descriptive names and mark deprecated fields clearly to guide your API users. Implementing pagination and filtering effectively manages large data sets and gives clients control over the data they retrieve. Type query, users, limit, int, offset, int, sort by, string, filter, user filter, input user filter, name, string, age, int. Lastly, don't shy away from using aliases and variables to enhance query, flexibility, and reusability. Query get user, $userid ID. User ID, $userid.
Documentation should never be an afterthought. Document your schema thoroughly. Utilize comments or description fields within your schema to explain types, fields, and arguments. This not only makes your API more intuitive and user-friendly, but also serves as a built-in guide for developers who interact with your API. Now, testing your resolvers is as critical as writing them. Engage in rigorous unit testing to ensure they function correctly under various scenarios and handle edge cases effectively. Don't shy away from integration testing either. This ensures that your resolvers are communicating accurately with databases and other services, safeguarding the integrity of your API. Consider this example of a well-structured resolver in JavaScript. It uses data loader for batching requests, handles authentication, and ensures robust error management through specific error classes. This structure not only optimizes performance, but also ensures that the resolver is secure and reliable. In conclusion, by keeping resolvers focused and simple, handling errors gracefully, documenting thoroughly, and testing rigorously, you craft GraphQL resolvers that stand as paragons of efficiency, maintainability, and scalability. These practices are fundamental in building GraphQL APIs that are not just functional but are exemplary, providing an exceptional experience for both developers and end users.